Today's lesson picks up with establishing a process that will work for solving any type of equation. Now, up until this point, we've been working essentially with two-step equations, and we have seen a slight variation to those with the variable and the constant on both sides, but in general, we have worked through a process in which we isolate to get the variable term alone. And what that results in is essentially a one-step equation. So from that one-step equation to finish solving, we can use an inverse operation or use inverse operations to solve, okay? So if you think about every equation we've dealt with adding or subtracting to isolate the variable term completely alone from the constant term. And then once we got to that point, we've generally used division on both sides, but sometimes we'll use multiplying to finish solving out for that equation. So today we add a new step, and this is the step that we revisited in class the other day that comes back from chapter 2, and that step is to simplify the equation first. And we know that simplifying is based on using two specific tools. There are two basic ways that we've learned how to simplify. And in this order, we should remember that the first tool we have for simplifying is the distributive property. And remember, that is basically using multiplication, correct? And the second is by combining like terms. And that is essentially using the operation of addition. So we always have to go in that order because GEMDAS says so, remember? Whoops. So GEMDAS requires me to do that. Lost that there for a second, but GEMDAS says you have to go in that order. You have to go first multiplying and then adding, first distributing, then combining like terms. So some of the problems we practiced the other day were limited to either doing one or the other, but when we see both, just make sure that we follow that order. So I want us to go about solving these equations by essentially seeing that each side of the equation is its own expression and following this sequence of seeing if we can simplify. So in the first equation, we see that 4 parentheses x plus 5 equals negative 24. Given that there are parentheses, it should be a clear indication that I can distribute. So I'm going to take that 4 and I'm going to distribute once and twice. So 4 times x is 4x, plus 4 times 5 is 20. That equals negative 24. From there, I can see that I'm looking at a two-step equation. So I want to start moving towards what we previously thought of as our first step by isolating. And given the fact that I have a variable term and a constant is equal to a constant, it should be pretty clear that what I want to do is move one constant to the other side to get the variable term isolated. So I will get 4x equals negative 44. Now here's that one-step equation that we're talking about after we isolate the variable term. At that point, I can finish by solving by using the inverse operation of multiplying. So I'll divide both sides by 4, and I'm going to get a final outcome of negative 11. Now I went through that pretty quickly, but once we distributed, this equation here should have looked very familiar to us as being a very traditional two-step equation. So I hope from there that even though I went through quickly, it was a very familiar looking process to you. So let's move on to our next equation. I take a look, is there any opportunity for distributing? If I don't see parentheses, then the answer is no to that. So I then want to move on to see if I have an opportunity to combine like terms. And I do see like terms. I see an 18x and a negative 11x on the one side of the equation. So I'm going to use my method of boxing those like terms so that I can recognize them as being ready to add. So I'll add those together. 18x plus negative 11x is going to give me 7x. The plus 9 drops down, equals 23. So again, I went through my checklist for simplifying. Could I distribute? No. Could I combine? Yes. And conveniently, I got a very familiar looking two-step equation again. So from here, we should be really in our comfort zone. So much so that I can see that I will subtract 9, which makes my 9's cancel out, which will now give me a one-step equation of 7x equals 14. After I get through isolating the variable, which I did by subtracting 9 on both sides, I can move on to using my inverse operation by dividing on both sides by 7. And once again, I will get to my solution, which is x equals 2. So in both cases, I'm not taking the time to check. And a very valuable step for you to take. So I'll encourage you to do that on your own. In this case, you just substitute the 2 anywhere where there's x, and you just follow GEMDAS to see if the equation works out to be true. So we're going to do one last one together, and it's going to require that we do both. So the first thing we're going to take care of is distributing. Now remember, we can't do 4 minus 5 is negative 1 and distribute that, because that would be breaking the rules of order of operations. So I need to see that there's a negative 5 directly outside. So negative 5 times 2x, negative 5 times 3. So that will give me 4. 4 trickles down, minus negative 5 times 2x minus 10x. Negative 5 times 3, that's going to give me minus 15, plus 8x equals 5. So I took care of the distributive property. And now I'll check to see if I can combine like terms. Now I should be able to recognize that I can combine like terms. So I like to combine my variable terms first. So I'm going to put a box around my 10x and a box around my 8x. And then I'm going to put circles around my positive 4 and around my negative 15. Whoops. And then I'm going to combine. So negative 10x plus 8x combined gives me negative 2x. 4 plus, I know you can barely see it, negative 15 is minus 11. And that's going to give me equals 5. Again, through all that work, through 2 steps of simplifying, distributing, then combining like terms, I get a nice clean 2-step equation. So from here, I can now move on to isolating my variable. And this should be a very familiar looking 2-step equation again. So we should see that we can add 11 and we get negative 2x equals 16. And then as our final step to solve, we'll divide out by negative 2. And we should get an outcome of x equals negative 8. So I've worked you through 3 examples, one in which we distributed only, one in which we combined like terms only, so this was DP only, this was CLT only, this was DP, distributive property, and then combining like terms. So you have 3 more examples to focus on, 3 more equations to focus on your own, and we will check in when we come to class next time. So finish up what's left on the notes, and we'll continue with our practicing class.